All right, problem number 7. Written description of the motion. So here is how we describe this object. It is actually moving backwards at steady speed. It then slows to a stop and moves forward, gaining speed. To get the displacement, we will take the area. So we have a rectangle and a triangle area to add together. So we will use this and this. So the rectangle plus the triangle area is going to be -4, that's this here, times the width of 2, plus 1/2 the base, which is 2, from 2 to 4, that's a base of 2, and then the height is going to be -4. So we end up getting -12. Then when we get the displacement from 4 to 8, we can use another triangle. That's going to be 1/2 base times height. That will be 1/2 times 4, because this is 4. And then the height is going to end up being 8, so that ends up being 16. And the displacement from 2 to 6 seconds, that's going to be the area of the little triangle plus the big triangle. And that ends up being 1/2 times 2 times -2, plus the 16 that we got up here. And that ends, did I have that right? No. 2 times -4 plus 16, so this ends up being an area of 12 meters, so it actually ends up going 12 meters forward. The acceleration at 4 seconds, again, that's the slope. So let me just pick 2 points. So I've got 8 and 8, and I've got 4 and 0. So I can say 8 minus 0 over 8 minus 4, which ends up being 8 over 4, which is 2 meters per second squared. Now, a possible graph of the motion. So it goes backwards at a steady pace. And then it ends up stopping and then going forward, gaining speed. So this part here is from 0 to 2, 2 to 4, and 4 to 8. And once again, the initial position could vary. All right. Next, number 8, we have a poorly tuned car. And it accelerates from 0 to rest at a speed of 28 meters per second in 20 seconds. And we want to make a well-labeled diagram, do a graph, get the acceleration, and get how far it travels. So let's just see. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 10 squares here. So why don't I count by 3? So this is 6, 12, 18, 24, and 30 meters per second. 20 seconds here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll count by 2, so this is 4 seconds, 8 seconds, 12, 16, and 20 seconds. So basically, I'm going from 0, 0 to 2028, and I can draw a line like that. This is a really bad drawing, but that's okay. Now the well-labeled diagram. I'll draw a car here, and then a car here. And here's what I mean by well-labeled. I start at 0 with my position. My V0 is 0. My V final is 28 meters per second. I don't know how far I went. I don't know my acceleration, but I do know my time is 20 seconds. Now, how far does this car travel? Let's actually use the graph. So the area is 1/2 base times height, which is 1/2 times 20 times a height of 28. That ends up being 280 meters. That's for part 2. Now the acceleration. So I will use the slope, v2 minus v1 over t2 minus t1. I'm just going to use the beginning and ending point. So 28 minus 0 over 20 minus 0. That ends up being about 1.4 meters per second squared. All right. Now, there's another way to do this, but you know what? We'll worry about that a bit later. So that's problem 8. I'd like you to try problems 9 and 10 and 11 actually a little bit on your own here, just to check in with me later.